Welcome to solverfy.
Okay, when we look at this structure and we try to determine if it will be more soluble in acidic or basic solution, we really want to look at those nitrogen atoms with the lone pairs of electrons on them. So since nitrogen has that lone pair of electrons on it, it can be protonated or it can gain a hydrogen ion, which is going to mean it will be more soluble in acidic solution because acidic solution will have an excess of those hydrogen ions. Okay. So acidic solution because of the excess hydrogen ions, and the nitrogens have lone pairs. When we look at the hybridization of those nitrogen atoms, in the nitrogens that have the double bonds in the ring are going to be sp2 hybridized because each of those has a double bond there, and anytime that there's a pi bond involved, there will only be 3 hybrid orbitals, which means it's going to be sp2. Okay, so that pi bond stays unhybridized. In the other ring with the single bonded nitrogen, that will be sp3 hybridized because anytime there are 4 sets of electrons, bonds, or pairs around an atom, like those 3 single bonds and the lone pair on the nitrogen, it'll be sp3 hybridized. Okay. So we have some that are sp3, some that are sp2. The carbons, same idea here. So in the single bond ring, right, all of those carbons in the single bond ring, similar to the nitrogen there, will be sp3, right? Because of those single bonds, they have 4 bonds, all require hybridization. So we have 4 hybrid orbitals. In the ring with the double bonds, those will also be sp2, just like the nitrogen, because of that pi bond that's involved with those double bonds. All right, when we look at the bond angles that are labeled, okay, so for A and B, which are in the ring, the single bond ring, the 6 carbon ring, there's carbon and nitrogen ring, those will be a tetrahedral geometry because there are 4 bonds. So that's a 109.5 degree range generally. Okay, so just because they have 4 things around that center atom, okay, those angles will be 109.5. And when we look at C, D, and E, we will see those will be about 120. Okay, because there are only, ignore that, sorry. There are only 3 electron domains around that. So when you look at that geometry there, 3 electron domains will be a bond angle of 120. All right, when we look at sigma and pi bonds, so sigma bond is the first bond that forms. So every single and double bond in this structure has a sigma bond involved. So if we count every single bond in this structure, we end up with 31 sigma bonds. That's our sign for sigma. And pi bonds form on top of sigma bonds. So in order to have a pi bond, you must have a sigma bond. So anytime there is a double bond, that means there's a sigma and a pi bond. Okay, if we had triple bonds, then we would have 1 sigma and 2 pi bonds present. So looking at this, we have 3 double bonds in the structure, which means those 3 sigma bonds were included in our 31, and the pi bonds that form on top of that to form the double bond will be 1 for each double bond, so that will be 3.